And welcome to the webinar IGA Model Preparation in Coreform Qubit 2021.11. And again, I'm your host, Matt Cederberg, along with Greg Vernon. So today we have a new launch of Coreform Qubit that just came out yesterday. And this is a release we've been working on for a long time. So we are just thrilled to be sharing what's new with you. The focus of this release is on IGA model preparation. We'll be talking more about what IGA is in this webinar, but there are also a number of enhancements across Coreform Qubit that we'll be introducing to you as well today. For those of you who are unfamiliar with Coreform Qubit, it is used across the world for advanced messing for challenging simulations. So Qubit has long been known for its strong toolset for CAD import and cleanup, especially its semi-automated hex meshing and lots of control. Python scripting is used a lot. But today we're introducing two new features to Coreform Qubit, IGA pre-processing, and then a lattice generation technology called Coreform Lattice GC. So throughout the remainder of the webinar, as you have questions, you can chime in on the chat, ask us in the Q&A. You can type back answers or direct them to Greg. The webinar is being recorded. At the end of the webinar, we'll have one poll question. If you can answer that, we'd appreciate it. And with that, I will turn the time over to Greg.
All right. Thanks, Matt. Yeah, we're all very excited about this release. We've been working hard for 2 years, really, if not longer. I mean, many people at Coreform have been working much longer to get Qubit to where it's at today. So we're really excited about this release. A few of the big highlights, there's a lot of stuff we've done in this release, but a few of the big highlights we're going to talk about today is that we've begun to modernize our documentation for the web. And so you'll see that change. There's still maybe a few rough edges that you'll see. And so if you find rough edges, we'd love to hear about them so that we can fix them up. But we think you'll enjoy kind of the new look and feel a little bit of our documentation. We've also now officially released our patent pending U-splines technology, which is a novel spline technology for simulation. We've also released some initial capabilities to use U-splines for an IGA workflow. This allows you to use Coreform Qubit for ANSYS LS-DYNA simulations, as well as for our Coreform IGA solver for our partners who are testing out that solver for us. As Matt mentioned, we also have a new module in Coreform Qubit called Coreform Lattice GC. The technology that we're excited about and we're showing in the bottom corner here. We've been working with one of our partners to commercialize this technology for building novel lattice structures for additive manufacturing. And lastly, we've got some new geometry modification capabilities in Qubit. One that we've had a lot of our customers ask us for, the ability to taper surfaces. And so we'll demo that as well today. Before we get started, we want to also let you know that we're not going to be able to dive into all of these things in detail today. And so we have a couple upcoming webinars in the upcoming weeks, and we encourage you to attend those. Both of them if you can, but if you want to pick out one or the other, we'll be talking about our Coreform Lattice GC technology in more detail on December 2nd. And then we'll go into more detail on actually building models for LS-DYNA and Coreform IGA on December 9th. And so we hope you'll join us for those. And then as a last note, before we really dive in, there has been also one big change with our Coreform Qubit Learn licensing, which again is a free non-commercial use license of Coreform Qubit. It's fully functional, but limited to 50,000 elements on export. So we hope that if you are a student or looking to learn Coreform Qubit, that you can use this license to kind of learn more about it. But now you'll go into Coreform Qubit Learn by logging into your Coreform account. If you don't have an account on Coreform, there's a little hyperlink that'll take you to our registration page. And this is a free license, so there's no, you don't have to pay for this Learn license, just registering your account. All right. So with those things out of the way, I'd like to then dive in. So I mentioned we have some modern documentation with a kind of a slightly new look and feel. I'll just show you, you can actually find this on our website by going to coreform.com. And then under our Coreform Qubit hyperlink, you can find our documentation page and our online help. This is also packaged with Coreform Qubit as well. And you can click through the links to read all about the new features in this release of Coreform Qubit, as well as learn about our U-spline technology in more detail here as well. We've included not just some detail about our U-spline technology, but also about workflows. For example, building these U-spline meshes for an ANSYS LS-DYNA simulation. And so you can read all about this there. So we're excited to have this new documentation rolling out, and we're going to be adding much more functionality and capabilities to this in the coming releases. So then kind of the big news for this release are our U-spline technology. As I mentioned, it's a novel spline technology for simulation. To shortly summarize in 2 pictures, the difference between U-splines and other spline or other element technologies is that we can now build smooth basis functions or smooth shape functions on unstructured meshes. And there's a lot of unique properties that come along with this formulation. To highlight a few of them, it allows you to smoothly and accurately represent complex industry-relevant CAD geometries with splines. U-splines support local modification of both their element size, degree, and smoothness, again, on unstructured meshes. And they have a slew of other superior mathematical properties, which make them an ideal element formulation for simulations. And then we've used these mathematical properties to allow us to use U-splines as the basis for our revolutionary new simulation capabilities in Coreform IGA. So what I'd like to do now is I'd like to demo building U-splines in Coreform Qubit for you. So this is a CAD model of a knuckle geometry. I just want to show that we support traditional mesh workflows that if you are an FEA practitioner should be very familiar to you. So the first thing I'm going to do here, I'm going to build a body-fitted U-spline mesh, and I'm going to defeature my geometry to support that. Just to show that we support kind of these traditional geometry modification techniques. So we can maybe remove these chamfers from our model, as well as remove this additional fillet and chamfer at this top, which might result in elements that are too small that we don't want to have in our model. We then can decompose our model to support building a hex mesh on top of. So I'm going to start by cutting off this, this top cylinder here. So I'm going to web cut. So web cut is, again, the term that we use for partitioning a geometry. I'm going to cut this geometry by extruding this sheet through the model. I'm then going to cut off the top by extruding this planar surface. That's now resulted in separate volumes. Then let's go ahead and cut off these forks or these tongs from our model. And then let's cut off these shoulders. And lastly, we'll go ahead and subdivide into quarters. Take all of these volumes and we'll cut by a in half. And then lastly, we'll apply some virtual topology to remove away these this small surface here that comes into a tangent. So we'll use virtual topology, which we call, the operation is compositing a surface or curves. So within the mode geometry surface modify composite, we'll select the target surfaces to composite. And the last step we need to do is now reunite our geometry or merge the geometry so that we can build a conforming hex mesh. We'll imprint and merge all of our volumes together. So the next thing we just need to do is right now we only support, or we support building U-splines on swept hex meshes. We'll soon be supporting all of our hex meshing schemes for building splines on. But for now, we're going to just define a sweep on everything. I think we'll do a size here of about 4 to give us a nice coarse mesh. And we'll also specify maybe some special mesh schemes on these shoulders. So we're going to build a mesh that's about this level of coarseness. So now for these shoulders, we're going to specify specific sweep direction as opposed to letting Qubit pick one. So we'll tell it we're going to sweep these in a negative Y direction, so sweep from top to bottom. So this is now representative of the coarseness of the model that we're going to build our U-spline on. And I'll show, so right now our U-splines are supported through command line options. Whenever we do development in Qubit, we always start by giving, or by developing the Qubit commands, and then we roll out GUI tool buttons for those. So what we're going to do is we're going to set the U-spline settings on all the volumes to be degree 2 with a max continuity of 1. Right now we support up to cubic U-splines. You can try even higher order U-splines if you want, but right now we only have test suites up through cubics. So you may be able to build U-splines on higher orders, but you may encounter some inconsistencies with higher degrees. And then we're going to build this U-spline on volume on all these volumes. So right now, Qubit is going through and building our U-spline basis. And then we'll fit this U-spline basis to our input geometry. And now we're rendering. You can then view the finished U-spline inside of Coreform Qubit through our U-spline view. And so as you can see, because we're using a higher order basis here, quadratics or degree 2, we get a really good fit to the input geometry. As well as, again, we've got smoothness in our bases across these element interfaces. With this U-spline, we then support exporting this U-spline definition to several different formats. one being a BEXT, which stands for Bezier extraction format, which is common in the simulation world to describe splines in an extracted form. And it's this format that you can use to export out to LS-DYNA or other. There's several open source codes that also support BEXT as inputs. If you want to visualize, you can also export to the Visualization Toolkit format, or VTK. And we're also working on developing additional formats as well, such as Exodus and STEP formats. And so you can then visualize this U-spline in ParaView through that VTK export format. So yeah, this is our new U-spline technology that's now finally in Coreform Qubit. So this is our first step to making, or one of our first steps into making Coreform Qubit a general purpose IGA preprocessor. If I can go, oh, and you can learn more about using U-splines for model prep in our upcoming webinar on December 9th, U-splines for IGA model prep. I also talked about being able to build IGA workflows for ANSYS LS-DYNA, again, using U-splines. And so I'll show a demo of this as well. But as you can see, we can take a model geometry, build a U-spline, and then actually run it today in ANSYS LS-DYNA. And so in this case, again, what I've done is I've taken a model geometry. I've used a traditional workflow prep to, again, apply compositing of all of these unnecessary CAD surfaces that are just, or interfaces that are really just artifacts of the CAD modeling process. I've segregated out my model so that I have a region to apply a boundary condition onto. So if I wanted to apply boundary conditions on these surfaces, I could. And then we build a quadratic basis, and then we throw this at a cylinder in ANSYS LS-DYNA. Again, we can build the U-spline with, again, a high order fit to that model geometry. And so as you can see, the U-spline with its smoothness and its higher order allows us to get accurate fits to the geometry, even while defeaturing a lot of those geometric surfaces or interfaces between those surfaces away. And so you can actually run these models again in ANSYS LS-DYNA, and I'll show you the results here. Just so you can see, again, one of the things to note, we've got a comment, or it's been asked a couple of times. Right now, LS Prepost visualizes for this higher order basis the interpolation facets. So actually, you're seeing about twice the density of what's actually going on in ANSYS LS-DYNA. The white dots are actually the control points of the U-spline, which can be thought of as the corollary of nodes in traditional finite elements. So each control point corresponds to a single basis function. And so again, we've got this the sheet metal part, which we're going to throw at this cylinder. And we can put a fringe plot of, say, von Mises stress to view our von Mises stress throughout the simulation as well. This is a capability that is still relatively new. We're working with our partners at both in the commercial space as well as at ANSYS LS-DYNA to improve the functionality of the U-splines in their simulation tool. So we encourage you to try out this capability and then let us know what kinds of features and functionalities you need for your specific workflows so that we can work to get those capabilities working in LS-DYNA for you. Also, as we also mentioned, we're also developing our own solver called Coreform IGA, and we can also build these IGA models using Coreform Qubit. And the unique thing about our Coreform IGA solver is it allows us to change the level of immersion so that we can build U-splines not on body-fitted models where you have to defeature in order to build a hex mesh on, but rather allowing us to relax the body fit constraints, maybe just slightly, so we have a simple to mesh geometry that then still captures all of the geometric information of our model, but vastly reducing the amount of model prep time. But we could also not just body fit or slightly relax the constraints, but we can also broadly immerse the geometry. And we've really allowed now a spectrum of modeling approaches for the analyst to be able to choose which level of refinement or detail that they need to have on their model. So on a critical component, just for efficiency of degrees of freedom per accuracy or accuracy per degree of freedom, you may need to, or you may want to use a mostly body fitted but slightly relaxed version. But in parts that are not necessarily important, that are maybe far away from the area you care about, you can then use these lower levels of initial capturing of the geometry, using still the local refinement of U-splines to still drive the accuracy to whatever level you need, but we're just with lower accuracy per degree of freedom. So in regions you don't necessarily need as much accuracy, then these more immersed methods can be valuable there. And again, we've got a lot more information and detail about how we build these Coreform IGA models and their accuracy and how they work in our past webinar, which you can find on YouTube, called Coreform IGA, Predicting the Onset of Failure with IGA. And we released this on May 12th of 2021. So we encourage you to go and watch this webinar if you'd like to learn more. But I do have a model, this model that we show in that demonstration shown here. Again, showing in this wireframe outline the U-spline that was used to capture this model geometry, and the results here are shown at the integration points of our model. And we've shown that this representation has very good agreement with traditional finite element approaches, but with many times fewer, orders of magnitude fewer degrees of freedom, in fact. And so this can result in not only a speed up in your modeling or your model prep, but also in your actual run times. I also mentioned we have a new module, Coreform Lattice GC, now in Coreform Qubit. This module is included in our 30-day free trial of Coreform Qubit, which you can request on our website. And just to show you where you can find that at. At coreform.com under trial. So there's a big red box up here, it says trial, and you can request your trial here. And with that, you'll get a trial of the Coreform Lattice GC. And so what this technology is, it drives the definition of the lattice structure based on a background mesh that you build. So you build a hex mesh, and then we insert unit cells into that mesh. And because that mesh is actually a U-spline, it then conforms to your geometry. And so you get elements that there's no gaps between it and its mating surfaces. Because it's using a U-spline mesh, you can have unstructured, but it's also smooth interfaces between the elements, which is good from a stress standpoint. And it also flows with your geometry. And we'll show an example of that here briefly. So here's an example bracket model. And what I've done is I've cut out a region that I'm going to turn into a lattice structure. And that's this yellow region here. And so I'm going to just draw this, this yellow region. I'm going to do a little bit of preparation, just like I would with traditional hex meshing. For instance, I want to composite these two faces together to remove this, this small face here, which might drive a small element. So I'm going to go into my geometry mode, surfaces, modify composite, and composite these surfaces together. I'm then going to define a mesh on my surface. I'm going to do again a sweep here. So I create an initial polyhedron styled mesh. And I'm going to then smooth this mesh so that I get a much better element layout. So I'm going to both apply a centroid area and a mean ratio. And then I'll define my sweep through the model. And once I built this mesh, we then do the same process as we did before, where we assign our U-spline properties. So we'll set the U-spline on volume 1 to have degree, sorry, on volume 2 here, have degree 2 and continuity 1. You actually don't need to specify these. The default U-spline that we build is degree 2 continuity of 1 as our default, but just for completeness here, I'd like to show that to you. Then we build U-spline on volume 2 with an ID of 1. And again, Core from Qubit will now build this U-spline basis, which will be degree 2 and smooth everywhere except exactly at the extraordinary point where it'll only be continuous, but it'll then be smooth partway out these elements. So this is a maximally smooth U-spline. Oops, and then we fit this U-spline. Redraw it. And just as you can see from the U-spline basis, you can see again like the smoothness between these elements that we see. And you'll see that the lattice structure will then inherit that smoothness. We have commands then to build a U-spline lattice. And so you can choose between one of 4 unit cells today, or there's even functionality to build your own unit cell and then incorporate that in your model. We can automatically slice this model for 3D printing. We can slice in parallel. And we've shown massive speed ups compared to other softwares out there. We have many unit cells in our lattice, as well as you can export this model for visualization or for pulling into a 3D model somewhere else. What's unique about this representation, however, is that you can use this background mesh within a model-based enterprise to define your lattice without actually having to render your lattice structure. So it's kind of a well-known phenomenon that pulling in hundreds of thousands of unit cells into a CAD modeling tool when they're stored as an STL format can oftentimes crash your CAD modeler. And so instead we can incorporate these meshes within a model-based enterprise, and it represents your lattice structure with much fewer or a lot less hardware requirements. And I've also pre-rendered some of these lattice structures for us here. Again, in ParaView. So we've got our background mesh. Just to show how these elements lay out, we can turn on this. This is a Jack unit cell. We're also again working on implicit unit cells as well. But you can see this lattice or this jack layout, again, with smoothly varying unit cells. This is defined as a surface, but we also have unit cells that we're working on that are defined as curves with a defined profile size. And so we have jack, we have an octet truss unit cell, as well as this truncated sphere, which is a bending dominated unit cell, which may be desirable for certain applications. And then another unit cell called PVB, which is a self-supporting unit cell for additive manufacturing. And it finishes loading up. So I hope you enjoyed this kind of introduction to Coreform Lattice GC. We're excited to work with you if you have interest in Coreform Lattice GC to use in your products, and we'd love to hear your feedback and experiences using this new module. The last thing I want to talk about is the new geometry operation in Coreform Qubit that we've added called taper surfaces. And just at a high level, what this does is it allows the user to select surfaces and then taper them at a certain angle from another plane. This is something that we've had quite a few customers ask us for. So we've now exposed this functionality in ASYS. I'd like to give you a demonstration of this workflow as well. So let me open this model. So to make or to do or apply this operation, let me just do one thing real quick. We'll go into the geometry mode and then modify surface. And on the drop down, we're going to pick this taper option. We can select surfaces. Another kind of useful user experience that we've improved is that now whenever you select a surface, you'll always have this context menu, which will allow you to select surfaces, multiple surfaces in a kind of specific manner. You can select similar surfaces, or you could say select a cavity, or you can select continuous surfaces, which will then select this entire ring of surfaces here that we want to taper. We then tell it the degree or the angle that we want to taper it with, so maybe 30 degrees. And then we define either a plane, either from a plane surface or about a curve or some vertices. So here we'll pick a surface normal. So normal to surface. And I think we want this bottom surface here. We can then preview this taper. So you can see I've got this taper to taper this surface inwards. So if we apply this taper here, you can see that we've tapered this model inwards. Or we could choose a different surface to taper around. So instead of surface 153, if we want to taper around 123, and taper the other direction. So I'll just show that again in the GUI just so you can see that video a bit more clearly. So I'll select continuous, 30 degrees, normal to surface 153 or 123. And look at what this taper will look like for us. So you can preview this taper and make sure it's doing what you want it to do before you apply it. All right, so that wraps up the new features, or the main new features in Coreform Qubit. And I would encourage all of you to go to our website and look at the user manual for more detailed new releases or new release features, as well as more information about all of these tools that you've seen today. So thank you for attending. And Matt, do you want to ask a one question exit survey before we go on to questions or Q&A section?
Let's see. I think, let's see, Kimberly, is this poll going to show up when they leave, or are we going to launch the poll right now?
It needs to be launched by you.
Okay, great. Yeah, so here's just some feedback that will be helpful from us after you've watched the webinar today. As we look forward to the future and planning future webinars, which topic would you be interested in learning most about? IGA preprocessing in Coreform Qubit, Coreform Lattice GC, or Coreform Qubit geometry modification commands, or U-spline mathematical theory? So I'll just leave this open for another 5 seconds or so.
Again, I encourage you all to stick around after the survey as well. We'll have some time for Q&A.
Great, thank you. Okay, all right, closing in a couple seconds. Okay, I'll just share the results with everyone in case you're interested. So looks like IGA preprocessing in Coreform Qubit and U-spline's mathematical theory are the top two ones, which is great because we've got some upcoming webinars planned on those. Okay, let's we've got a few questions that have come in, and we'll go ahead and take some time to, we've answered some back via text, but here's some more we can respond to live. From an anonymous attendee, do we have any experience with using Coreform IGA and hyperelastic materials? Does Coreform IGA support contact analysis? Greg, do you want to talk to that?
Yeah, can you say that one more time? I was trying to pull through.
Do we have experience using Coreform IGA with hyperelastic materials? And does IGA support contact analysis?
Yeah, those are great questions. So we do support nonlinear elastic materials like hyperelastics. We have some other nonlinear materials we're adding as well. There's right now in Coreform IGA, with what we while we do support contact and some other capabilities, right? We are building from the ground up, but we do have pretty good support, I would say, for these nonlinear elastic materials. But we're always adding new material models. So if you have a specific formulation within the hyperelastics that you're interested in, we'd be interested to hear which specific model you're interested in looking at. But we've also found that a lot of these hyperelastic materials are oftentimes nearly incompressible, and so we're working on some incompressible material formulations as well. And then from contact, it's actually one of the exciting things about IGA in general is that the smooth surfaces from the smooth representations of splines that you get, it's been shown to be really powerful for contact. And with improved robustness and accuracy. And we do intend for Coreform IGA to support contact as like a key feature or critical feature in it. We're still working with our partners who are exploring these contact formulations in Coreform IGA. And so that's not necessarily ready to go today in production, but it's definitely at a stage where we'd love to work with anyone to make sure that we build contact capabilities that are useful for them.
Great.
But yeah, that's definitely in the plans though.
Okay. Question from David: does the educational license expire, and which versions of Qubit does it apply to? So the educational license lasts for 12 months, and then you can get a new version. The only reason why we have it expire every 12 months is just so you can have a chance, if you're ready to use it for commercial use, it's a nice prompt, but that can continue on. And it works for each version of Qubit. So we did, as Greg mentioned, we did just barely switch over how we're handling educational licenses. So all of the ones using our previous license software will expire in the next 60 days, but you'll have a chance to get a new educational license with our new licensing.
Yeah.
Okay.
I just saw a question come in as well asking about what kind of CAD file formats we can use. And so we support kind of the STEP format, which is a neutral ISO standard format. That comes with every release of Qubit supports STEP, as well as the ASUS native format is a .SAT format. And then we also have, let me share my screen one more time, if I can find where the, oh, am I still sharing?
You are, yep.
Oh, okay, great. You can also find on our website, we have additional modules that are available for purchase that allow you to import, let's see, where's formats? We have these Qubit translators, and through those we support a number of different input formats, including SolidWorks, NX files, CATIA files, and others. So if there are other formats you are interested in having support for, we'd love to hear. You can also import STL files and PLY and OBJ files. So even a number of these mesh-based formats are supported as well. So,
okay. Thanks. Question from Anthony: how far along is the integration of Coreform with Moose? So Moose, if you're unfamiliar, is an open source solver used a lot in the nuclear energy industry. I've been working with that team for a while, and I'm glad you asked. Just in the last, I think, couple of weeks, we've completed our first integration there. We're in the process of testing that with that team. So we'll have more news shortly on that, and probably have a webinar soon showing that workflow. Okay. From Huang, is there any place I can find the documentation for the BEXT format?
Yeah, that's a great question. So the BEXT format, when it originally came out, was parts of some dissertation papers. We should have this in here. And so it's never been necessarily well defined. But we do have some definitions in our manual that if we've not yet released these in the documentation, will be coming shortly. But we define the format for BEXT in our documentation.
Yeah, if that's not online, we can get that up there within a day or two.
Yep, we're having some formatting issues with that. So I know that if it didn't quite make it, it'll be up there soon. But yeah, great question. We'll maybe send out an email to folks once we made sure that that's online.
Okay. Question from Ben: does Coreform IGA support dynamic simulations like vibration analysis, linear wave propagation?
Yeah, so we fully intend for Qubit to be a fully featured linear and nonlinear solver for both solid mechanics as well as heat transfer, coupled mechanics. And so included in there are dynamics. We don't yet have an eigenvalue solver that's accessible to users, but our linear solvers right now are based in PETSI, and so we have access to, there's some eigenvalue solvers in there. But we do support explicit dynamics already as well. So right now we've got like implicit dynamic, explicit dynamic, and then we're working on these other kinds of solvers. But if you have specific kind of techniques you're looking for, we'd love to hear about which techniques are important for you.
Okay, here's a question from Ham. If we have a highly heterogeneous model, are U-splines still able to drastically reduce the degrees of freedom compared to FEA?
Yeah, because with your level of heterogeneity, if you're trying to resolve it, you still need to have degrees of freedom to resolve those individual pieces, and especially with Coreform IGA and its novel flex method, which is what we call it with U-splines. we found that we still get these really good approximations, even when we're just immersing a lot of these features. But what we just found is that when you use high order basis functions, they get such, kind of an exponential convergence with cell size. And then the smoothness of the U-splines is what then drastically reduces the degrees of freedom. So we've already shown with actually stacks of these lattice structures, with like was it 10,000 unit cells, I think, Matt, so far? Or is it 100,000 that we've done?
Yeah.
That we get, really quick results for those models. If you've got specific problems that you're interested in with the massive heterogeneity, I think one thing that comes to mind is inclusions in materials. It's one thing that comes to mind, but we'd love to hear about those problems.
Okay.
But yeah.
Great. Thank you. Question from Felix. Has there been any tests to use the results from Bezier extraction in Abacus?
So I don't know if anyone has. We have not, at least, done any work to support Bezier extraction in Abacus. But I think you could through a custom element formulation. For those that aren't familiar, Bezier extraction is just a linear transformation from a C0 basis into the U-spline or other spline basis. So the Bezier extraction file just encodes those linear transformations as a matrix or as local matrices that operate per element. So I think one certainly could do that in Abacus, but we just haven't looked at it ourselves. And I am not aware of anyone who has done that, but someone may have.
Yeah, there have been a number of investigations in most of the large commercial codes about IGA over the past few years. And I know there have been investigations with Abacus, whether they're using BEXT or just NURBS, I can't recall. But yep. Okay, question from Sumit. How can we extract the control point data from the created geometry in a data file so we can post-process the data in IGA? So question for post-processing.
Yeah, so one of the things I'll mention is that we do have a format that we're working on developing, which is the JSON format. And in this JSON format is where you'll find information about the control point location as well as the extraction operations, I believe. So I think that's where you'll want to look. Also, we're working to, as we've talked about before, implement some of this inside of Exodus. And you should be able to recover the control points from there as well. There's some documentation that we'll be publishing with the Exodus team. Exodus is an open source mesh format developed at Sandia National Laboratories, and we'll be defining that format in the coming weeks with some docs there. But I think that's where you pull that out.
Yeah, the preferred post-process right now is ParaView, and because we've added support for IGA there. And is that available in the standard ParaView download, Greg?
Yeah, so the way that we render U-splines here is they have a new, in ParaView 5. I think it's at least 5.8, but certainly in 5.9 or newer, they have an unstructured cell type, which allows us to render Bezier elements, which are what each of these are. These are each the Bezier cells natively in ParaView, but the control points aren't in this format. But if you were writing a solver, you should be able to, if you can take your solution and extract it down or represent it down on the Bezier level, you should then be able to then have ParaView natively render the Bezier cells with their simulation data. It's just not native U-spline, if that makes sense.
And finally, a question from Christos about the new way that we're doing Qubit Learn licenses. Yes, because if the Learn license needs to be approved because it doesn't appear in my licenses after it's been requested, and maybe we can clear up some of the documentation on this, but once you request the Qubit Learn license, it won't actually show up anywhere. You just log into Coreform Qubit, click Educational, and then just add your username and password. And that is the way that the license is working now. So there's nothing new. There's not a license that you'll be adding there.
Yep. It just checks to make sure that you have a license, or they have an account, sorry, on Coreform's website. Yep.
So, okay, we got one more question from Clint. Can you mesh a shell in Qubit and fit a U-spline to it to use in LS-DYNA?
Yeah, and actually, that's what we showed earlier. Building a surface mesh on this shell and building a U-spline on it. I think I've already built this U-spline. And then exporting out to an LS-DYNA file. And so it comes through as a .k. And we have a workflow described in our documentation. So if you go to our documentation from the top level to Qubit workflows, you'll then find this section for building U-spline meshes and what's needed to create your .k file. So we have some information about how you include those formats in your .k file, as well as the kind of an initial set of keywords that are supported by this IGA functionality.
Great. So another question, is it possible to decompose the whole piece without all of this process? I'm assuming that's referring to how we are setting up U-spline models today. So one answer to that is Greg shared a webinar a few months ago showing the Flex IGA process, where we can get away with much less model prep. And that is, I think, one of the big benefits of IGA is being able to get away with far less model preparation. What we're showing today is a way of using existing traditional techniques to create U-splines for inclusion in Coreform IGA and DYNA. But absolutely, there are other ways that this can be done as well.
Yep. Yeah. And so our vision is that we'd like to be able to have essentially one click, in a single click, to have prepared your region for meshing, and then just simply mesh the geometry. So with effectively minimal or no user input. I guess I need to tell it a size though. As our model prep. So we are very much focused on workflow and trying to improve the workflow for end users to minimize challenges here. So this would already be in this model I built here for LS-DYNA, where all I need is a contact surface. This would be ready to go in LS-DYNA.
Yeah, great. Okay, well, again, thank you everyone for coming. This is a big day for us. We're glad to be able to share these new updates with you. Again, this webinar will be recorded, and we love interacting with email, or especially, Greg, if you want to just show our Coreform forum, that's a place that we love interacting with the community as well. So as more questions come up, if you want to jump on there, then we'd love to continue the conversation.
Yeah, and so this is our forum at forum.coreform.com. If you ask questions here, we're pretty good at responding as soon as we can, but we have categories for Coreform Qubit as well as for Coreform IGA. And so we encourage you to ask any and all your questions that you have here.
Great. Okay. All right. Thanks, everyone. Have a great day.